Hello, this is Ryan Treat, one of the product managers here at Venafi, and I want to take a few minutes to introduce you to the world's very first workload identity issuer, Venafi Firefly. At Venafi, we see how the rapidly evolving landscape of cloud-native technologies is changing the focus for cloud security teams. Firefly is a cutting-edge workload identity issuer, purpose-built to support modern use cases for securing and managing workload identities. For this demo, I'm going to be specifically focusing on how Firefly supports the Secure Production Identity Framework for Everyone, or SPIFFE as it is widely known. This capability is key to solving a host of security and management challenges associated with workload identity in cloud-native environments. So, let's dive in. Let's start by logging into the Venafi control plane. This control plane was designed to give security teams the governance and visibility required to confidently distribute trust throughout their enterprise. Getting started is easy. All you need to do is create a service account. This is what the Firefly instances will use to authenticate with the Venafi control plane to get their configuration settings to enforce, including policies, and their issuer certificate that chains up to their your enterprise PKI. The sub-CA provider is that linkage between the control plane and your PKI. In this case, I'm using our own zero-touch PKI to issue my certificates, and these are going to be 21-day issuer certificates for the Firefly instance. Then I need to create a policy. I've got one created here specifically for SPIFFE because we're focused on workload identities. These certificates will have a maximum validity of 7 days, so ultra short-lived. And you can see they don't allow any subjects. All that'll be ignored. They'll be subjectless, and they'll have just a single SAN in them, a URI SAN that has to match the pattern for a SPIFFE certificate, and they'll be elliptic curve certificates. Last thing is the configuration. I've got a demo config here. This is where everything gets linked together. So we've got the zero-touch PKI provider for the sub-CA certificate. We've got the SPIFFE policy, and we've got the service account. Don't need any other configurations here because in this case, I'm going to be focusing on workload identity, like I said, and I'll be interacting directly with Firefly over a Unix domain socket rather than using Cert Manager or one of the other network-based APIs that Firefly supports. Now let's hop over to the command line and take a look at the local configuration. Again, very simple, very easy to get started. All we've got in here is some details about the service account and a name that is going to be for this instance. And then the last, probably most important thing is that this particular Firefly instance is going to expose a gRPC interface using a Unix domain socket. And this is the path that it's going to expose that on. Now let's take a look at my start script. Again, very simple. This is just a Docker run. In a production environment, you would use Kubernetes to deploy your Firefly instances, but for demos, Docker works just fine. You can see here the main thing, I have mounted a few volumes. The important one is this Unix domain socket volume. This is how my client script which simulates the workload identity orchestrator, is going to interface with Firefly, and it uses that config file I just showed you. So let's run the start script. There we go. It's pulling down the configuration from the control plane, generating a CSR, getting that signed by the control plane. Now it's submitted to zero-touch PKI, and within a few seconds, there we go. Now we've got a Firefly instance up and running. All right, now let's take a look at my request certificates script. In here, I've got some variables to specify the policy name. So this is the policy that I showed in the control plane. They are going to be elliptic curve to comply with policies. The trust domain, I'm going to start with using a domain that is wrong, obviously, because wrong.demo, just to see that Firefly does enforce policies that are configured by the control plane. Here's that Unix domain socket that I'm going to use, the file. The script will loop 10 times if I don't specify otherwise. It's going to generate a random SPIFFE ID and a random validity period and make that request, again, using gRPC. In this case, I'm using a command line utility called gRPC gRPC curl. And here you can see again, it's using the domain socket. So no network traffic here. And if the request is successful, I'm going to parse it and show some details. So let's go ahead and request a bunch of certificates. Oh no, like I said, the policy compliance failed because I've got the wrong demo trust domain. So let me fix that. For that needed, let's go over to the control plane really quick. See that on the policy side, it needed to be venify.demo. So let's change that. All right, it's changed. So let's try that again. And here you can see all the certificates being issued by Firefly in real time. Of course, this is fast, but this could be so much faster if I wasn't parsing every certificate, outputting it to the screen, and if I wasn't doing the requests one at a time, if I was using some kind of parallel processing. Now let's take a look over at the control plane and see what we see in the issuer certificates. So we've got a record for the issuer certificate. This is the certificate that was issued to that Firefly instance just now, and you can see that so far, as of the last check-in, it had issued 123 ultra short-lived certificates. Firefly checks in every 60 seconds. So within just a couple more seconds, it should increment that count. There we go. And so now we're over 1,000, 1,500 certificates, and we're still going well on our way to getting the 10,000 that I requested. So I hope you've enjoyed this demo and see the potential for Firefly as the workload identity issuer for the modern enterprise.